In this example, we're going to go ahead and evaluate this definite integral. So it looks like we have the integral from 0 to the square root of 3, and our integrand here is x times e to the power of negative x squared divided by 3, and of course that's all with respect to x. So if you'd like to give this a go ahead and pause the video and try it, and then come on back and we'll do it together. Okay, so looking at this integrand here, it seems like a u substitution is going to be our best bet since we have e to the power of, and this is kind of a function in and of itself. So we will say that u will equal negative x squared over 3. And so that when we differentiate both sides, we'll have du equals, and this looks like negative 2x over 3 dx. And when we solve for this dx, we'll do so by multiplying both sides by negative 3 over 2x. So negative 3 over 2x du. And that's kind of what that will look like. And of course, when we use a u substitution with a definite integral, we need to also adjust our limits of integration right here. So our value for u was negative x squared over 3, and these limits of integration were x equals 0 and x equals the square root of 3. So let's go ahead and adjust those as we need to. So if we plug a 0 in here, it's just 0 squared is 0, and then the opposite is 0, and then divided by 3. So that's just going to give us a 0 right there. And when we put a when we put a square root of 3 in here, it's the square root of 3 squared is 3, and then we have this negative, so negative 3. So I'll write that negative 3 over 3, and that will equal negative 1 for that new value. So instead of going from 0 to the square root of 3, we're going to go from 0 to negative 1. So let's go ahead and kind of rewrite all this and see where we are. So we have the integral from 0 to negative 1. We have this x right here times e to the u, and then of course our dx was negative 3 over 2x du. So we have changed our limits of integration in terms of u now, and we also have a du, and kind of this whole thing is now in u. But we've got a couple x's here, but it's nice because the x in the numerator and the x in the denominator do cancel each other out. Let's go ahead and take this negative 3 halves. We'll bring it out front as a constant. So what we have here is negative 3 halves times the integral from 0 to negative 1 of e to the u du. Okay, not bad at all. Notice, if you will, one adjustment we could make is that our limits of integration go from 0 to negative 1, which is kind of backwards because we're used to seeing the smaller number down here going up to the larger number, so left to right, but these are backwards. So let's go ahead and flip them, and we can do that, and the adjustment we'll make is by putting a negative out front, but there's already a negative out front. So what we can do is just cancel that, and we'll have a positive 3 halves times this integral of e to the u du. Okay, at this point, this integral is actually pretty easy to do. So we'll have 3 halves times, and the integral of e to the u, well, is just e to the u. And we will go from negative 1 to 0. So from here on out is just evaluation. So 3 halves times, and it looks like it'll be e to the 0 minus e to the negative 1. And we can kind of fix this up a little bit. We know e to the 0 is just going to be 1. So it'll be 3 halves, 1 minus, and then this e to the negative 1 is really 1 over e because that negative exponent. And so we could leave it that way if you want, or we could go ahead and distribute this through, and you'll have maybe 3 halves minus 3 over 2e. That would be another way to go about doing that. Or you could go ahead and get common denominators right here, and you could multiply this by e over e. So you would have 3e minus 3 all over that common denominator of 2e. And that would work as well. So there's lots of ways that you could leave this simplified here, or perhaps even here before the common denominators, or here. let's go ahead and recap what we did. We had this integral. We went ahead and used a u substitution, which we saw here. But of course, when we use u substitutions with definite integrals, we need to go ahead and change these limits of integration as well. And so we did that. And then once we had everything adjusted, we went ahead and tweaked at this point our limits of integration. Instead of going from left to right, they were right to left. So we just switched them and changed the sign out front, which was nice because it went from a negative to a positive. And then it was our integration with a lot of evaluation down here with our numeric parts. So here we go for the evaluation for this definite integral example.